Why is sharding essential for NoSQL database scaling? Have you ever wondered how large applications manage to store and retrieve massive amounts of data without slowing down? One of the key techniques that makes this possible is sharding. So, why is sharding essential for scaling NoSQL databases? Let's break it down. Sharding is all about distributing large datasets across multiple servers or nodes. This means that instead of having one big database, you have smaller, more manageable pieces called shards. Each shard is stored on a different server. This setup allows the database to handle increased data volume and user load more efficiently. At its core, sharding is a form of horizontal partitioning. This means data is split by rows instead of columns. Each shard holds a subset of the data, often determined by a shard key. This could be something like user ID, geographic location, or a range of values. When a query or write operation happens, it can be directed to the specific shard that contains the relevant data. This reduces the workload on any single server and speeds up response times. For backend developers working with application programming interfaces, databases, and server-side logic, sharding is important for several reasons. First, it makes databases smaller and faster. By limiting the amount of data each server must handle, latency is reduced and throughput improves. Second, sharding enhances scalability. As data or traffic increases, new shards and servers can be added without major redesign. This means your system can grow horizontally, which is often more cost-effective than vertical scaling. Third, sharding improves fault tolerance. If one shard fails, the others continue to operate. This means the overall system remains available, which is critical for applications that requiring high uptime. Sharding also simplifies management. By distributing data and workload, tasks like backups, maintenance, and updates become more manageable on smaller data partitions. There are several common methods to implement sharding. Range-based sharding divides data based on ranges of shard key values. Hash-based sharding uses a hash function to determine the shard for each data item. Geography-based sharding partitions data by user location, optimizing latency and compliance. Choosing the right shard key is crucial. A poor selection can lead to uneven data distribution, causing some shards to become overloaded while others remain underused. This imbalance can hurt performance. In practical backend development, sharding impacts how application programming interfaces query data and how server-side logic routes requests. The application or database system must be aware of the sharding scheme to direct queries efficiently. Many NoSQL databases, like MongoDB, Cassandra, and offer built-in or automatic sharding features, making implementation easier for developers. Sharding is a fundamental technique that supports the scalability and performance of NoSQL databases. By partitioning data across multiple servers, it enables back-end systems to handle large-scale data and user demands effectively.